now. Last lecture we finished talking about moments, and we used characteristic function and also the moment generator function to generate moments as well. And today we're gonna finish the last topic we're gonna discuss in chapter 3, which is the transformations of random variables. If we are interested into transferring or changing a random variable from x to y, okay, and where y, of course, there's a one-to-one relationship between x and y, where y basically is a function of x, okay. We're going to consider two cases when y is monotonically increasing or decreasing. Monotonically meaning continuously increasing. It's not increasing and then decreasing or back increasing. It's continuously increasing or decreasing. Okay. So the first case, we're going to consider the increasing case. Okay, let's assume that y is a continuous one-to-one monotonically increasing function of x. Okay, so which means, as shown in equation 1 here, y, the function y, or the random variable y, is a function of x. So the inverse function of y will give us the random variable x. Okay, so if we need to find x, we just take the inverse of the function y as shown in equation 2. So the CDF of y, the new random variable, as we know, it's shown in equation 3, which is the probability of the capital Y is less or equal to small y. Okay. Now, again, there's a relationship between, as shown in equation 1, between y and between y and x here. Then we can replace y here in equation 3, capital Y, with g of x, as shown in equation 1. Okay, and also x, which is the random variable x, is less or equal to the inverse function of y. So these are the relationship. Now at the end, the main thing is that the fy, which is the CDF of y, is equal to the fx, or the CDF of the inverse of the function y, which is x, okay, small x. Similarly as in equation 8. So really, the reason why we're doing all this, because there's a one-to-one relationship. And if this is the case, okay, then it means that events y less than small y must be equal to event x less or equal to small x, which means the CDF of y would have to be equal to the CDF of x. So that's why we managed to use this. Now, these are just analysis here. Let's take equation 8 or 7 and do the differentiation. So we're going to differentiate with respect to to y. Why we want to differentiate? Because we need to find the CDF, the PDF, sorry. So this is the CDF, okay? This is the CDF. Now this is the PDF. The PDF basically, we learned that in chapter 2 actually. This is simply the differentiation with respect to the PDF, of course. Since we have a function inside, so the differentiation of CDF will be PDF times the derivative of the function inside, okay, which is the derivative of the inverse of y, okay, with respect to y, okay, which this one is equal the derivative of y, okay, the derivative of x with respect to y, okay. So equation 9, we can rearrange it as in equation 10 or equation 11. Both of them are equal. So if we want to use, if you want to take the PDF times the derivative of x with respect to y, where x is equal to the inverse function of y, or you just take the PDF, divide by the derivative of y, just replace it, okay, reverse it, okay. So these are the main results we are looking for. So again, if we have a function of x, okay, the new PDF or CDF is right here, and the new PDF can be found this way. So let's take a look at this quick example. For example, one here on this page, page 2. So if we consider a Gaussian random variable with a mean is equal m and the variance sigma squared, and we need to form a new random variable, which is y, and y is the function of x, which is equal to ax plus b, where a is larger than 0. A is larger than 0, it means this function y is always increasing, because if a is less than 0, okay, if a is negative, it means this one is always gonna decreasing as x increasing. So this one, in this case, a will increase, but if a is x will increase or y will increase. Now, if a is negative, then the whole thing will start decreasing. But in our case, it's increasing, so we can use this equation 11. So equation 11, what do we need? Okay, we already know the PDF of the Gaussian random variable. We've seen that before. Okay, now we take so we have y. So we found the derivative of y with respect to x. So let's say if we want to use equation 11 right here. So x will be u minus b divided by a. Okay, this is, of course, x came from this equation right here. Okay. Now, we do have x, and we have the derivative of y with respect to x, and we just plug into equation 11, okay, in here. So x, where do we use x here? We use it inside this equation 12. Equation 12 here, x. Now we're going to replace it with this new form, which is u minus b divided by a, which is the inverse of y. Okay. So after we plug in all this information, so this is the new PDF. Okay. So we just replace the PDF divided by a, and 12.6. This is the new result, and you can see that now the random variable y, because the first one is the random variable x. Now the random variable y has different mean. What's the mean here? As you can see here, the mean عبارة عن ايش? 2m plus b, 2m plus b right here. Okay. And the variance is a square sigma 4. Okay. And this is another example. It's very similar. The only thing, this example is related to exponential random variable. The random variable here, the PDF is 2 times the exponential minus 2x u of x, okay? And the new random variable y is a function of x, where it's x to the power 3. Again, we find the derivative of y. We take the first derivative of y with respect to x. It's going to be 3x to the power 2. Okay, and also y, x is, you take the inverse of y here. It's going to be y to the power 1/3. And you just plug in the information like we just did here. Okay, and this is the new PDF. So it's very straightforward. All you have to do is just find the first derivative with respect to y, and you find the inverse of y, the inverse function of y to find x, and just plug into the new PDF. So that's related to when the function y is increasing. What if it's decreasing? What if it's decreasing? Meaning, if we have, let's say, this function right here, this example, and a is negative. Okay, so this is going to change a little bit. So we will do the same analysis, okay, like we did before. Y is equal g of x. And of course, this is the inverse of the inverse function of y. And this is the same thing like we did for. The only difference is because g of x here in equation 14 is negative, okay, we'll multiply both sides by negative, then this is going to be reversed. So this is equation 15 is going to be the probability of x larger or equal to the inverse function of y, okay? Because g of x is decreasing, is negative, okay? Which this one, now in this case, fy is equal 1 minus fx of inverse function of y, okay? So this is the difference between when the function is increasing or the function and decreasing, okay? Now we take 16 and we do the same thing. We take the differentiation with respect to y, okay? And we'll end up, after we do the differentiation, we'll end up with equation 19. So the difference here, we have a negative sign up front right here, okay? So the difference between the increasing and decreasing, a negative sign right here. Now, if we take the same example we just did, and we replace a with minus a, and we plug in the numbers, so x would be equal to b minus y divided by a, which is the inverse y, and the derivative of y with respect to x is equal minus a, okay? And so you plug in all this into equation 19, the x and the derivative of y with respect to x, and you will end up with what? With fx y minus fx of y minus b divided by minus a, okay? Divided by a. Now, if we compare this equation, equation 20, and equation, where is it? Right here, equation 12.3, okay? The only difference was there's a negative sign inside the fx, which is the x, negative sign right here, okay? So really, as you can see, the difference is in the x right here. And when y is increasing, x will be y minus b divided by a, where in this case b minus y. So there's a sign. But as far as this one will go away because when you do the derivative, this one is going to go away. So we can generalize this, okay, by coming up with a different equation. This will be valid for both increasing and decreasing, okay? Equation 22, which is fy is going to be the absolute value, fy, the PDF of y would be fx divided by the absolute value of the first derivative of y with respect to x, okay? So either way, you can use these two examples separately or this one if you forgot it, okay? And this is really the end of chapter 3. That's all we need to cover in chapter 3. And these are just suggested problems for you to practice for the exam, okay? And that's all I have. Do you have any questions? Okay. If nobody has any questions, I will talk to you guys on Wednesday, inshallah, on Sunday. يعطيكم العافية.